Hi everyone, we are doing checkpoint number 3 this week for homework. Excuse me. So if you go to the ebook and you scroll down on the left side where all of the lessons are, I believe it's under, let's see, I'm looking at it right now. If you go to reference, for me it's under reference, and then it has checkpoints there. That's where all of the checkpoints are, and you've got the handout, so you kind of don't really need to look it up in the ebook, but I just want you to know about that because the checkpoint actually has, oops, let me get back to this. It has examples, so it always is related to a problem from the book, from the regular lessons, and it has kind of everything you need to know about that topic. So this topic is angle relationships, and what I've noticed is students just need more practice with this before the first test. It's a lot thrown at you at the very end. That's why we're working on con exercises. Hopefully all of this will benefit you for the first test. They really expect you on the first test to really be proficient with this. So it's nice because it does have all of the important information that you need from the chapter, everything you should know at this point, and it has examples and it shows you how to do the examples. By the way, it does have the answers to the checkpoint problems, but it doesn't have much of an explanation. It just kind of has the answer on there. So I just wanted you to see this. And we are going to start with number 1. So we'll do some of these for the first part of the week and finish them up for the second part of the week. So if you look at this triangle, and I do expect you to write the relationship on the paper with me, not just the equation, you have to show all your work. I've printed out the diagrams for you because it's just too much for you to draw. I mean, you could, but I thought it would be nice to give you the diagrams. So this is, do you remember what this is called? This is an isosceles triangle. And the base angles, these are the base angles of an isosceles triangle. In an isosceles triangle, you have the two sides that are equal to each other. Those are actually called legs of the triangle, and the side that is not a leg is called the base, and these are the base angles. And the base angles in an isosceles triangle are, do you remember? This was on another homework assignment, I think. They are congruent. So therefore, my equation would be that 3x plus 2, and there is actually one like this on your test. Trying to remember if it's exactly the same as this. It's slightly different actually on the test, so make sure to watch the video for the study guide, but it's related to this. So 3x plus 2 equals, let's see, that's kind of right. Let's see, it might be a little bit better, equals 4x minus 2. I don't know if that's good or not good. Let's see. Oh, that's really right. Okay. So we've got x's on both sides. Let's get all the x's on one side. I always say get rid of the smaller one, subtract 3x from each side. That's going to give you x. Bring down the minus 2, bring down the plus 2, and then just solve for x. Get x by itself by adding 2 to both sides. So x equals 4. Now in this case, we're just solving for x. We don't really have to do anything beyond that. Looking at number 2, there are parallel lines. We've got parallel lines cut by a transversal. So you should recognize that these angles, now some of this we will have done by the time you see it for homework. Other problems you might be wondering, what is she talking about? And we will get to it after the homework, but it doesn't really hurt to see it in advance. So these two angles are, let's write the relationship, and these are, let's see, let's write it over here, same side interior angles. So remember, when you have parallel lines, or whenever you have intersecting lines, you want to draw that circle. So I'm going to draw two circles. And because these lines are parallel, these four angles will match these four angles. Now this angle is not going to be the same as this angle. If I took tracing paper, and I don't have any tracing paper at home, so I'm just going to take a regular sheet of paper, and I can kind of see through it. I'm going to trace this angle here. Remember, we did this with tracing paper. If I slide it over, and I'm realizing you probably can't see through it on the screen, but if you do that with just some regular paper at home, you'll see that it forms a straight angle, half a circle, which is going to be 180 degrees. So if you're not seeing these relationships, tracing paper is your friend. It's going to help you out because you can just do that sliding and see the relationship. So these two angles are supplementary. That means they sum to 180. So then y minus 48 plus 3y equals 180. Let's combine like terms. Y and 3y is 4y. So I have negative 48 plus 4y, or I could have written 4y minus 48, same thing, equals 180. I'm going to add 48 to both sides. So 4y equals 8 and 4 is 12, 228, and then I'm going to divide both sides by 4. So y equals 57. Okay. Looking at number 3, this is actually something that we will get to hopefully at the end of the week. All of the angles in a triangle add up to 180, but a relationship between these two angles, they're called remote interior angles, and the exterior angle is that the exterior angle is equal to the sum of the remote interior angles. So that means that these two together, 34, well, let's write it so it corresponds with the words. The exterior angle is 101, let's put that right there, is equal to these two together, 34 plus z. So I'm just going to subtract 34 from 101, and that's 67. So z is 67. For number 4, now this is the perfect example of something you're going to see in a test. If you get confused just because you don't see that full line, take your ruler. You can always use a ruler and extend that line, and hopefully that's going to make you think, hey, intersecting lines, 360, half of the circle, 180. So I know these two angles together are going to sum to 180. So called a linear pair. Linear pairs are, now you might have heard it as in middle school as a straight angle. So linear pair or straight angle. Linear pairs, you would say linear pairs are supplementary. You really wouldn't say straight angle is supplementary because you need two angles for them to be supplementary. You could say straight angle equals 180, if that makes more sense. And I know you're only going to need to know the relationship to get the equation, but don't skip this part. A lot of students will skip over this And then the equation doesn't mean anything because it's not connected to a geometric relationship. And you want to make that connection now because you're just going to keep seeing this over and over again. So we know that 3x minus 1, is that a minus? I think it is, plus 52 equals 180. I've got -1, positive 52, that's going to be positive 51. So 3x plus 51 is 180. I'm going to subtract 51 from each side. So 3x equals, let's see, 180 minus 50 would be 130. So I'm going to take away one more, that's 129. And then I'm going to divide by 3 on both sides. So x equals 43. All of these are degrees. I think I forgot to write degrees on this one. Okay. Okay. Let's do number 5. We've got some parallel lines cut by a transversal. Let's draw circles where we see those intersection points. Okay, so we know that these angles are going to match because of parallel lines. So I'm going to look at specifically this angle and this angle. So those two angles are alternate interior, angles, and alternate interior angles when the lines are parallel are congruent. Okay, only when lines are parallel. So that means that 3x plus 14 equals 4x plus 9. X is on both sides. Let's get rid of the smaller one. Don't have to, but it just makes life easier. So take away 3x from each side. Noticing this is kind of bright still. Let's turn that off. Take away 3x from each side. So that gives me 14 equals x plus 9. Then I'm going to isolate x by subtracting 9 on both sides. So x equals 5. Okay, number 5. All of the angles in a triangle add up to 180. We will get to this later in the chapter. But you probably learned that at some point along the way in middle school, maybe. So that means that all 3 of these angles are going to add up to 180. So that means 5x plus 3 plus 2x plus 17. This angle, angle A, plus angle B, plus angle C, which is 90 degrees, equals 180. Now, when I do this in the future, I probably will skip over this part and go straight to the next step. If I see a right angle, then I know that these two angles right here are going to add up to 90. Now you can start like this at any time, doesn't matter. I just usually don't. I skip over it because I know that these two angles together are going to sum to 90. Minus 90 is 90. Let's go ahead and combine like terms. So 5x and 2x is 7x, positive 3, positive 17, positive 20. Subtract 20 from each side. So 7x equals 70, and then divide by 7. So x equals 10. And I know I'm going kind of fast, so definitely if something was confusing, go back and review it, pause it, maybe say, did I really understand that? I wrote it down, but did it make any sense? Oh, and I'm just realizing I didn't write any relationship for this. Let's just put triangle sum. Angles in a triangle sum to 180. Okay, number 6, we have another triangle and we've got an exterior angle. We also have a particular type of triangle. We have an isosceles triangle. In an isosceles triangle, my base angles are congruent. So let's put for the relationship base angles, isosceles triangle, congruent. Okay, and then the exterior angle equals the sum of remote interior angles. So this angle on the outside, 110, is going to equal these two angles added up together. I'm trying to get the lighting to work here. Okay, so that means 110 is going to be equal to these two together. Well, if this is x, we can call this x, right? Because they're the same. So, let's see. There we go. So 110 equals 2x. Divide by 2 on both sides. Opposite of multiplication is division. So x is 55. Okay, number 7 we have, or wait, this is number 8. That was number 7. Number 8, we've got a right angle. These two angles together would be complementary angles. So they sum to 90 degrees, and that means that these two angles together, 3x plus 3, and you can skip this first step if you want to just go straight to combining like terms, that's fine. I'm just writing it out in case anybody needs that. So these two angles together equal 90 degrees, so 3x plus x, that's 4x. 3 and 7, that's 10. Subtract 10 from each side, so 4x equals 80. Divide by 4, so x equals 20. Saving a little room there. Okay, number 9, and I think we'll stop here for today because I know you've got some con exercises you're probably going to be working on. We have parallel lines, and we have several things going on here. Oh, we've got an x and y. That means we're going to need to do two equations. So let's put if lines are parallel. This only works if the lines are parallel. Then let's look at what we have. We've got these two angles here. Now there's a lot that I could say, but I'm just going to stick with what is going to benefit us. These two angles here are, do you remember what they're called? Same side interior angles, because they're on the same side of this transversal, on the same side, and they are in between these two lines. So you've got interior angles are in between the two lines, and they're on the same side of the transversal. If I were to do the tracing, I need to bring some tracing paper home. If I were to trace, and you could try this at home with just a sheet of paper because you'll be able to see it. So if I trace either angle, I'm tracing the one on the bottom, sliding it up, and I'm drawing the one underneath just so you can see it. These angles are going to create half a circle, so that's a linear pair. So that's going to add up to 180. So same side interior angles are supplementary. Can you hear the thunder in the background? Hoping the electricity stays on. Okay, so we've got 5x plus 2 is going to be added to 63 to give me 180. Now if you skip over this part, you're probably going to get this wrong. So don't skip the relationship. Combine like terms, we get 5x plus 65 equals 180. Subtract 65 from each side is going to give me 115. Divide by 5, I'm going to get 23. And then to solve for y, Okay, so we have x. Now I'm going to look at these two angles here. You could use this angle. You could plug in 23 and get the angle measure here and set it equal to this angle, because those are alternate interior angles. You could do it that way. Or you could say, I know this is a half circle. I know that they're going to be supplementary. So 63 plus 3y minus 12 equals 180. So that's going to give me, let's see, 63 and negative 12. That's going to be 51, positive 51. Subtract 51 from each side. So 3y is, let's see, that'd be 129. Divide by 3. Y is 43. Now, I didn't really write a relationship for that one because I kind of ran out of room. But that's a linear pair. Let's just put linear pair supplementary. Okay, we're going to stop there for today. If you need to work on con, this was only 20 minutes. Try to get another con exercise done. And see you on the next video.